Welcome everyone. Today we have our another new episode, and this episode is very important. We're going to discuss on Industry 4.0, and we have our world famous speaker, Professor David Smith, Professor Donald, and Mr. Adam. I want to start from Professor David Smith, how you want to analyze this Industry 4.0, and beside that, what is the opportunity we have to engage with this Industry 4.0.
Well, Sharif, thank you very much. Industry 4.0 is such a broad term, and there's so many definitions to it. There's a real no question at all that technology is playing a huge part of our everyday life, and we're living in this increasingly connected culture. We're living in this increasingly digital culture, and that we're seeing that Industry 4.0 is beginning to build up on that. Uh, Industry 4.0 is often thought of the name given to the combination of traditional manufacturing and industry platforms, which are then married with the newest generations of smart technology, the Internet of Things, other smart sensors, and large scale machine to machine deployments that are working across all of industry. And so let's just step back a second and build ourselves into Industry 4.0. The first industrial revolution was in the late 18th century in Britain, and it really helped enable mass production by using water and steam power instead of just purely human and animal power. A century later, you got the second industrial revolution, where it introduced the assembly line, like used to generate automobiles, the use of oil, gas, electric power. And you begin to see then communications come in play by the telephone and the telegraph. But this really brought mass production to scale. The third industrial revolution, which began probably in the middle of the 20th century, added computers. It added very advanced telecommunications and data analysis to the manufacturing process. It saw the introduction of computer chips, particularly the embedding of programmable logic controllers, PLCs, into machinery to help automate some of the processes and collect data. And that really begins to move us into Industry 4.0, where flexibility is one of the keys, because part of the hallmark of Industry 4.0 is going to be mass customization. And it's wanting to change the ability of, as opposed to doing lot sizes in the hundreds of thousands, pulling them down to a lot size potentially of one. And by collecting data, not just from the factory floor, but other places throughout the organization, and even the consumers as the products get deployed in the market, to enhance the design, enhance the process, and bring it to this whole new digitally transformed, connected world. I love to ask people the question, tell me a device that costs more than $100, takes power, and doesn't have a chip in it. The answer are there's some, but they're hard to find. And that's really what's driving Industry 4.0 is everything has become digital, everything communicates, now increasingly everything senses, and as it senses, it can communicate each other, and that's where artificial intelligence goes into Industry 4.0 to make it smart and learning. So it really is an evolution of the prior three industrial ages, but really it's accelerating because of the global nature of it, the connected nature of it, and the fact that everything is in zeros and ones today.
Mhm. Thank you, Professor David Smith, for your excellent analysis. And I know you are a CTO of one of the largest corporations, and developing nations need actually a lot of technology transfers, and even we have different startup and innovations. So your guideline, your corporation guideline, will be very helpful for Asia Pacific. Professor Donalds, you are also a very good mentor, even for me, and always you guide World Talent Economy forums and guide different small medium enterprise with your different interesting strategy and with your knowledge. So how you want to analyze this industry 4.0, and from your experience from the Silicon Valleys and the Stanford University, if you share some of your views with our audience, it will be very helpful for us.
Well, David really did cover what Industry 4.0 is. I'll say one thing. I've been around long enough that you start having X wonderful new technology, and then X wonderful new technology 2, and then X wonderful new technology 3. And by the time you get to X wonderful technology 3, it's already starting to get so diffuse, and it means so many different little things that it's really hard to consider it one thing. And by the time you get to 4, I think it's pretty much more of a marketing term for some purpose than it actually is something. As David pointed out, there's a lot of different aspects to what's going on. They're applying the basically statistical multivariate regression and other statistical techniques that they unfortunately call artificial intelligence is fabulous, because when you look at the history of basically robots, it goes back to the idea of cybernetics, and cybernetics are systems of control. So they started out when Norbert Wiener was first working on it. The project that he was trying to do was to be able to basically shoot down airplanes from a ship and have the guns know from the rocking of the ship how to keep themselves pointed in the same direction. That was the original use of cybernetics. And all the way back in 1945, Wiener foresaw the idea that we would be able to start using them for things like assembly lines and other places where people were doing very mechanical types of tasks. That's like everything else, that's turned out to be a little bit harder than we hoped in the first place. So Amazon's been trying to automate their warehouses, but people are necessarily required for because things go wrong. I think that when you're looking at something that you think of as artificial intelligence, what you have to realize is that we have a very good ability to separate what we're trying to focus on from the noise. So if something goes wrong or something's different than we expect, that's noise that we can ignore and keep focused on the task, but that's a lot more difficult for a robot to do. Silicon Valley has a kind of, what we've done always is we start companies, but then when they grow, they go someplace else. So for instance, Hewlett Packard did its while it was still a company, did its manufacturing in Roseville and Fort Collins and places like that, where the labor costs were much, much lower. And Silicon Valley, a square meter of Silicon Valley costs so incredibly much money that if you're building something and you have to store parts and materials on the floor to use to make the thing, it's costing you so incredibly much money just having the stuff sitting there on the ground, because the square meter of Silicon Valley is so incredibly expensive. So it's been, Silicon Valley starts companies and then they often leave and go someplace else. But so in Silicon Valley, you really don't see much manufacturing. I mean, it started out that way because Intel was there and other things. But the fact that we have the internet and the fact that we have these abilities to do things remotely allows places to be able to have central control over what they're doing, or at least central direction. Way back in 2006, I met with a company called Valmet in Finland. And at the time, they were creating a system where their engineering teams could work together they have paper manufacturing plants that they build all over the world. That's one of Finland's big exports. They're the second biggest company, and probably the biggest now after Nokia. And they build and export paper manufacturing plants. And they got it together all the way back then in 2006 to have their engineers being able to work together to do designs for the plants and other things that they needed to do. And that's an example of something that we're using the internet for, so that a company doesn't have to really be in one specific place. Where they are is more for tax purposes and administration. So I think, as I've said before, the developing world doesn't necessarily have the money to build a semiconductor plant or things like that, but they can partner and pair with the companies that do, and of course, and countries like Taiwan have gotten very, very good at, and Korea have gotten very, very good at building semiconductor plants. So they can work together with the companies that have the engineering expertise and build their manufacturing capability and industrial capability that way. And that's what I can say for that.
Thank you. Mr. Adam.
Thank you very much, Sharif. So, what a topic, Industry 4.0. Also
Yes.
known as the... sorry?
Yes.
Oh, you said something. Yeah, so the fourth industrial revolution, also known as by the mouthpieces over at Davos and the UN. Now, I know it's become something of an established maxim that technology is neutral, and part of me agrees, and certainly initially anyway. And I'd like to offer an alternate view. I personally don't think, another part of me personally doesn't think technology is neutral ever, whether it's just being introduced or whether it's been out in the market for whatever amount of time. For me, concepts like good and evil are not subjective. In my mind, they are objective, intertwined with the very fabric of the universe itself. And technology can be a mix of the benevolent and the malevolent in differing ratios, which for me is not the same as being neutral. A technology, I think, can have characteristics calculable which could inform futurists and forecasters to predict whether it would more likely take us down a more dystopic route, or a more benign utopic route, or even a third option where it's a weird mixture of both, where it's like heaven for one group of lucky people and a hellish grind for the more unlucky demographics. And intuitively, I have a bad feeling in my gut about this incoming fourth industrial revolution, which is being rolled out by unelected people. Well, we are not given consent whether or not to have our lives so dramatically altered. One of my biggest concerns is the issue of privacy, which I fear will be non-existent eventually. Not only could it become non-existent, but people's lives could change so dramatically that they wouldn't care anymore. They would no longer care that they have little to no privacy, or worse, might not even notice its absence. And I don't want to raise the spectres of Orwell or Huxley too much, as it's become a bit of a cliche and a tired trope within futurist discourse. But I like to use the term Orwello-Huxleyan for this kind of a subject, a weird mixture of soma and a boot stamping down on your face. And if an emerging tech poses more of a threat to freedom, which outlays a smaller ratio of amazing benefits, then should we adopt it just for those amazing benefits whilst ignoring the writing on the wall as far as our liberties and freedoms are concerned? People invested in such tech like to mask the obvious downsides with the positives, even if it's obvious that such positives would be outweighed by the negatives. I mean, you have Arnold Schwarzenegger coming out with slogans like "screw your freedom," to which I say, give me liberty or give me death. Give me privacy and freedom to walk around the countryside while you're at it. Thank you, Sharif.
Thank you, Professor David Smith. I have some question. Number one, like when we work like this Industry 4.0 developing, so it's mean that academy has to change their strategy when they develop human resources. That's for sure. Second things, like as you are a CTO for one of the largest company from USA, what will be your guideline for academy. I'm sure that we will share our content with University Grant Commission of few developing countries, and definitely they will take our your advice seriously. So, what is your advice and how they can restructure their uh, academy training and development procedure?
Well, Sharif, that is an excellent question, and I loved Adam's comments there too. So let me put on my hat more as a member of the Association of Professional Futurists than just the straight CTO hat as well, and talk about where academia needs to go to address these new trends and things. So academia has done a fairly good job of in the engineering schools, the computer science schools, the polymath schools, of beginning to adapt things that were in Industry 3.0, the computer revolution. And they've done a great job of going from the very basic side of pushing forward new architectures and hardware, new approaches in software, optimizing new applications, advancing artificial intelligence and others. But where Industry 4.0 is outstripping academia are in some areas such as uh, the Internet of Things. The Internet of Things is not only a key component of smart factories, it's becoming the key component in smart communities, smart cities, smart nations as you begin to look at it. Uh, the Internet of Things is one that touches upon so many of the academic programs within universities. It's something that has to be addressed cross disciplinary. And that is one of the changes I think we're going to see universities begin to make. Another uh, key driver in Industry 4.0 that began in Industry 3.0 is the further expansion of cloud computing. The initial cloud computing was just really very big data centers open to more people. But really, where cloud computing is going now more so is the processing's moving to the edge of the cloud. And that edge of cloud is going to be very important in 4.0, particularly as we begin to do more things in real time. Real time processing is going to be one of the hallmarks of Industry 4.0. And we move from near real time or batch processing, the early part of Industry 3.0, into real time processing. And as we do that and we push the sensors and the edge of cloud computing out, AI and machine learning will also move out to that edge of cloud, because what that does is demand for real time production operation means it has to be done where there's very low latency time. And that's out the edge of the cloud. You know, for example, the detection of safety or quality issues in today really demand real time interaction to do them. Now, the big place where academia can step up is in the area of cybersecurity. As we expand this access to it, privacy, like Adam said, is almost an afterthought at times. And just this week, the one of the heads of Google said the United States needs to adopt a more rigorous regulation like GDPR enhanced to handle privacy here. I think we're going to see, with the actions out of China last week, a more of a global view of cybersecurity and privacy coming to bear as Industry 4.0 moves forward. But cybersecurity is an opportunity not only in academia, but also for a lot of entrepreneurships. I often ask myself the question, why in North America are there almost 200,000 cybersecurity companies?
Mhm.
The challenges of cybersecurity is so vast, so difficult, so many nuances. It's hard to get the top leaders in cybersecurity together to achieve a goal. Great opportunity for academia and for entrepreneurship there too. The other
Mhm.
place that I think academia could add a lot, because this is rather new, and most of this is coming from the commercial sector and not out of academia, is the whole concept of the digital twin. And, there's digital twins that create processes, production lines, factories, supply chain. There's digital twins that actually are being used to simulate what we as humans are doing in different things. It really got its start decades ago in NASA, as they did twins, not digital twins, but functional twins. For example, the Apollo spacecraft, as they went to the moon. And when there was the accident, they used their twin to troubleshoot it. Well, we now see that as digital twins, enhanced with all the sensors and things to make it possible. Research in that is lagging. The ability for universities to spend effort taking digital twins and shaping them to work in the regions, shaping them to work in the communities and the different cultures, is an area where I think academia has a lot of possibilities. And finally, with all the different and vast elements in Industry 4.0, there really needs to be academic programs that look at the overall impact of those systems as systems with each other. And because we're exchanging so much data all the time now in so many geographic locations, we have to look at, can we build a platform of the various platforms so that we can begin to interchange that data in the future, so that we don't stovepipe that data, so that it becomes more available to make the types of decisions that need to be made, all the while protecting cybersecurity, all the while protecting privacy. That is a grand challenge of how to connect those systems to systems through a platform of platforms that is worthy of research at any of the research institutions around the world.
Excellent, excellent. And I'm really happy if we get, like, all of our speaker get chance. We work as a team, we develop a universities, or we can transfer technology and knowledge in different university. Actually, we are working with few countries prime minister office as well as university grant commissions, because we have to attract them and we have to share our views with them. And definitely today's discussion I'm going to share with them. Professor Donald, I want to go to the next level of this discussion. Let's say a student, he finished his study or undergraduate, and then he or she plan for develop his or her careers. So in that situation, what will be the best strategy? Like the student, the young people, they can get into the startup, they can develop their careers, or they should go to the well-established organization or large company or multinational company. What is your view?
Well, that's very much a cultural thing. In Finland, the people tell me that their mother tells them from the time that they can understand Finnish, 2 years old or whatever, that they should go to work for a large corporation, and that it's not a right thing to do to start your own company. It's just too dangerous, and they're very cautious. So it depends a lot on the culture. I know, and you showed me how the companies work in Malaysia, and you part of then starting a company in Malaysia is working with the government usually, and so that's an interesting, a different path. So being a startup, as we've said many times on this show, is you have to be overly optimistic. Adam Smith even said that in The Wealth of Nations. He said that entrepreneurs are basically too optimistic. Because you have to believe that things are going to work out, because things are going to keep going wrong, and they're going to keep going wrong, and you're going to discover things that go wrong that you never even knew existed. And as people have often said on the show, there's the known knowns, the known unknowns, and the unknown unknowns. And you're going to discover the unknown unknowns constantly, which is why I've always encouraged people to grow their social networks, because when something unknown happens, there's probably somebody out there who actually has encountered it before and does know what is going on and can help you, but you can't figure it out yourself because you don't have a source of information. So what you can do, it's very interesting when David was just talking about a higher level system of systems. One of the main ways that that's done is through standards. So if somebody can, we can agree. That's why one of the reasons the internet was so successful is because we set on a standard, TCP/IP, and everybody uses that standard. So when you're starting out or you're developing a project internally, you're faced with the problem that there are multiple standards sometimes, and that can be kind of a danger, because if in the United States there was a time when there were two standards for VCRs, which preceded CDs and DVDs, and they one was called beta, and that lost. So if you bought a VCR with a beta format, tough. There were no tapes that you could buy for it. It just went out. The format went away. So you're making a decision at one point, like, which standard am I going to adopt? And sometimes if you adopt the wrong standard, oops. Big companies have people at the table at the standards meetings. They are pushing their own standards and trying to make sure that the standards that they've adopted are the ones that everybody uses. And there's often minor modifications of the standards, where you'll add a field to the standard that has more information. So the previous versions work, but the new versions have more information, and the companies will work together to do that, or one will push the particular information they need, and the others will say, oh, well, it doesn't hurt anything. But so what I'm getting at there is that careers can be more than being an engineer, because in this particular case, we're getting into legal things, and I'll expand that. In the I forget the exact year. It was in the late 70s. It was in the 80s. There was a guy, Zimmerman, who made this new software called PGP, Pretty Good Privacy. And it was so good of encryption that NSA couldn't crack it at that time. And so they arrested him. And they said, well, you're, doing horrible things to national security. And so he made all the source code open source. So he said, well, you can see what it's doing, so it's free speech. I'm just printing. And the courts agreed with him, and they said, yeah, it's free speech. You can go ahead and do that. But right now, like, I was working at NetApp, and NetApp actually got in trouble because they sold something to a vendor who then sold it to Syria, and it had some encryption on it. And the United States can't export certain kinds of encryption, because then somebody that is our enemy might be able to encrypt things, and we won't be able to see what they're doing. So that is against the law, and companies can get very, very serious sanctions for exporting encryption technology. So what I'm saying here is that you, besides the obvious thing of engineering, there's a whole social and legal part that you can make really good money at. I mean, a lawyer in Silicon Valley charges about $500 an hour if they're good ones, and it's worth considering doing that. And in that particular case, it's a little easier to be independent, because you don't have you don't have the overhead. I mean, if you're trying to do manufacturing, you've got the problem that you have to buy all the stuff that you're going to put together, and that's pretty formidable because if there's a downturn, you've borrowed the money to buy the stuff, and you're not selling things fast enough to pay back the loan that you had, and that can ruin you. So, as I said, it's a choice. Entrepreneurs are going to face many, many challenges. If you're an entrepreneur in the service industry, you've got a lot less overhead and a lot less danger to doing it. But if you're working towards trying to do some of the exciting things in engineering and software, you're probably better off going to work for a big firm.
Thank you. Mr. Adam.
Thank you, Sharif. So I will jettison some of my previous alarmism, and I was just thinking about what I was saying about consent and privacy earlier, and and consent and privacy wasn't always such a loaded issue when the first few generations of PCs and laptops were rolled out on the market. I mean, back then it was more simply a case of choosing whether to buy one or to not buy one. That was as far as it went for a while. But now devices are getting smaller and smaller, becoming more and more intertwined and ubiquitous, like with smart dust, the Internet of Things, for example. And the issue of privacy will become an increasing concern for those who care about it. But alongside that, the number of people who will continue to care about it as we go along may dwindle, I fear. Um, you can see vast differences between the different attitudes that different generations have towards the same issues. My grandparents would scoff at the very idea of social media and laying it all out there for the whole world to see. For them, there was still much shame in hanging one's dirty laundry out for all to see, for all the world to see. And in the space of 2 or 3 generations, you have people my age and older and younger oversharing great personal details about themselves for their thousands or millions of subscribers and followers. It's gone from being a source of shame to being encouraged, or even a requirement to being a celebrity these days. Being a YouTuber and not doing that could lose you hundreds of views and subscribers for the sin of being boring. And then they would still get crucified for saying something even mildly offensive. And the shelf life for being a celebrity is becoming shorter, like Andy Warhol predicted. In the 60s, during the hippie revolution, that was used as a good example of a dramatic social and cultural chasm between generations, namely young students of the late 60s and their buttoned up post war parents. And at first, I thought that is nothing compared to the differences we see between generations today. But then I thought, no, I think the opposite is now true. The opposite is now the case because social media has created molds and cookie cutter ways of dressing, haircuts, ways of speaking, music to listen to. So you have different ages, different generations becoming more monocultural and all being part of the same subculture or similar subcultures to each other. But I digress a bit. So along that line of thought, I fear individuality will suffer, creativity, divergent thinking, non-conformity will suffer, rebelliousness will be crushed so effectively that feudal warlords of the past would be very jealous indeed. Um, so I've gone back to being a bit of an alarmist now. But yeah, thank you, Sheree.
Thank you. Professor David Smith, when we're discussing about Industry 4.0, research and innovation is very important things. So specifically for this kind of research and innovations, how actually American corporations or US corporations, they actually invest in research and innovation. And beside that, uh, how developing nations can invest in research and they can get benefit from their particular area.
Oh, that's a great question because if you look at large corporation spending on research and development has been declining over the last decade as a percentage of their income. And what we've seen more and more is research has been emanating either from small companies with entrepreneurship driving basic uh, application research, and really others and academia driving basic research going forward. You know, Donald earlier mentioned uh, really Ethernet, and Bob Metcalf was the inventor of Ethernet, and and he has some great quotes around innovation. And one of them, uh, Bob lives here in Austin, and one of the quotes he's said a number of times when I've been with him is that the world needs a better understanding how to encourage innovation, and innovators need to get better at it. And that to me is a real truism because of how we look at innovation and what we do with innovation and how it fits in places. Uh, I have to say one other thing to what Donald said that was just so spot on. I was an executive at two of the largest consortia in the United States, the MCC consortia, which was designed to recover the computer industry from the Japanese fifth generation computer project, and Sematech, which was the industry consortia to recover the semiconductor industry back. And I had the privilege of, for example, at Sematech working with Bob Noyce, the guy who invented the chip and founded Intel, with Andy Groves and others. Um, and what we did at Sematech was something Donald talked about. We not only created standards in the semiconductor industry at the manufacturer scale, and we had a whole group inside the consortia deal with that. We also created something called semi standards, which were designed to work in the over 400 suppliers to the semiconductor industry. And that type of standardization drove a lot of innovation and did a lot of things to help us move forward and make the innovation curve less steep, because when you have a set foundation to build upon, it's easier to build. I mean, that's where you begin to see countries begin to build high rises is after they master the art of building a solid foundation that can support those structure and all the forces that go with it. The same's true in business, the same's true in academia. You have to use those standards or advance the standards to do a solid foundation. And then you have to put the pieces together. One of the things we've done at my holding company, Economic Transformation Technologies, or ETT, is we have built an ETT innovation lab. And one of the purposes of the lab is to pull multiple companies together to begin to apply standards across them, to begin to apply platforms that allow them to work with each other. For example, in that lab, we built a platform that will let our education company, our fintech company, our health tech company, and our hospitality company all use the same platform, so that things like security, machine learning, natural language processing, workflow management, a lot of those core services that they all need are the same. And each can learn from each other no matter which of those vertical industries in. As I begin to answer your question about how the innovation can happen, you can make innovation happen more readily with a lot faster curve is when you can build up on each other to learn, use common tools, common approaches that can learn and advance themselves. And that was the goal of consortia, pulling industry together to do that. And you saw it happen in the computer industry, the manufacturing industry, the auto industry, in the semiconductor industries and others, to combine those innovation capabilities to do what was at that time called pre-competitive research, and then build up on that pre-competitive research to drive new innovations. And that's what we've seen happen with those as we go forward. I co-led the first semiconductor roadmap, and things we did back in the early 2000s are still being held today in the updates to that roadmap. And we weren't far off as we had that foundation to build up on and advance the industry and look at the inflection points where innovation needed to occur. And when you understand an inflection point, that is one of the places where you can marshal the appropriate innovative resources, the smart brains, the smart applications, and build those new innovations to be successful.
Thank you, Professor Donald.
Well, oops, yeah. I want to keep going with what David said, he and I are incredibly agreed, bouncing off of each other. There's this wonderful book called Regional Advantage by a Berkeley professor named Annalise Saxenian. And that book inspired the group I was at Stanford, the Silicon Valley Network Analysis Project. And what she studied was what happened in the 80s. And in early 80s, Boston was the high-tech center of the United States. I mean, hands down. I mean, they had MIT and Harvard, and they were twice or three times as big as anyone else. By the end of the 80s, they were dust. I mean, they were so far behind Silicon Valley that it wasn't even, there wasn't even a contest anymore. So, I mean, that's worth looking at, isn't it? I mean, that's how something like that would happen is something that any place would really find interesting. And what she found is one of the main things, one very, very important factor in it was just what David was saying, is that in Boston, the premier company was DEC, Digital Equipment Company, and they were doing very well because they had these mini computers that were challenging the mainframes at much lower cost, but very high performance relatively. But Olson was a very, very much, Ken Olson, the person who ran DEC, was very insular. He wouldn't even allow the people that worked for him to go to church parties with people from other companies. He was so secretive. And the way it worked was everything was completely vertical. So if you bought a DEC computer, you had to buy DEC memory, you had to buy DEC keyboards, you had to buy DEC terminals. It was 100% vertical. And a couple of things happened. I mean, one interesting thing was that a lot of the UC systems started using DEC computers, and somebody wrote a piece of software for Unix that allowed basically to map the characters from any computer terminal to the characters to a DEC terminal. So then all of a sudden you could get $300 terminals instead of $4,000 terminals. And of course, that caught on like wildfire, which is one of, I'll mention Unix again in a second, but the disk drive companies started to use standards. So all disk drives were interchangeable. All of the parts started to become standardized. And once they became standardized, the prices of everything just dropped like a rock, and DEC was gone. I mean, practically overnight. It took no time at all. And that allowed Silicon Valley to thrive, and it allowed people to compete with each other. And of course, when you have competition, that can raise the quality and lower the price. The other factor is I think that innovation is not something that some person has. Like Thomas Edison had a group of about 15 people that he worked with forever. And they had diverse views, and they helped him with all of his different things. And he was willing to do trial and error. If you start looking, really get into the different people, like for instance, Ford didn't exactly invent the assembly line. The assembly line was already being used to process meat, pigs and chickens and things like that. So he just took an existing technology and repurposed it. I mean, that was really brilliant of him to do. So what I'm saying is that a lot of innovation is people taking something from one social world or one place in society that's kind of disconnected from another place in society and borrowing that and bringing it into a new and different place. And that was another advantage that Silicon Valley had, which is why the Silicon Valley Network Analysis Project was that there are immigrants from so incredibly many different places that we wound up having a huge amount of diversity, still do. And the one thing I want to say that just mentioned, Unix really, I wrote the first commercial validation suite for Unix, and I ported the 8086 to the 286, the assembler for AT&T, and I did some communication projects using communication protocols like LAP-B and things like that. And Unix really blew things out of the water because Unix was designed to work on any chip. And so it basically removed the user interface from the machine. So companies like DEC and IBM and would sell operating systems, and the operating system often made them more money than the hardware. And what wound up happening was that all of a sudden you could get this operating system for free, and it would run on all of your hardware, and the exact same programs would run everywhere. And that was rewritten by a guy named Linus Torvalds, and it became Linux. But it was actually, there was what's his name? I'll remember it in a second. But rewrote the C compiler and all the utilities, and then Linus rewrote the kernel. But Linux then is basically, as much as possible, was a clone of Unix. And then there's also BSD, which was Unix, FreeBSD, which became the operating system for Macs. And all that allowed all the different computers now to interoperate with each other. Any terminal would work on any computer, and because of that, it allowed Silicon Valley to incredibly thrive and allowed a huge amount of innovation because, as I said, innovation is a lot being able to take something from one place and apply it somewhere else, and that allowed that to happen freely. And so I definitely encourage situations in academia, for instance. The Finns have, when I teach in Finland, I find that my students are from China and Spain and all kinds of places. The Finns take this very seriously and go out of their way to make sure that they have a diverse workforce and diverse connections into the world. And I recommend that if you're interested in innovation yourself and would like to be more innovative, try and learn enough social skills that you're able to hear what other people say. You can if you read the Wikipedia entry on a subject, you'll know enough about it to ask questions and learn from everybody. And that's all you have to know. It's just spend 20 minutes reading the Wikipedia entry, and all of a sudden you can connect with almost anybody if you've read that Wikipedia entry. So I would really highly recommend doing that because you'll find things that you absolutely had no idea existed. The unknown unknowns will start popping up in front of you everywhere, and and you grab one of those, and that's innovation. So there.
Mm-hmm. Thank you, Mr. Adam.
Thank you, Sharif. When I first entered transhumanism as an enthusiast many years ago, I always balked at the criticisms of transhumanism that usually went like, oh, if we do this and X, Y, and Z, would it mean we would no longer be human or we would be less than human before? And I always rolled my eyes without fail, so I feel a bit embarrassed to be a techno-pessimist sometimes regarding some topics, and I feel even more embarrassed about being a mixture of both techno-pessimist and techno-optimist. I feel like it might be too much like sitting on the fence. But having said that, and remembering what I said before about issues like privacy, when we go full steam ahead into the fourth industrial revolution, some positives now. Less medical mishaps will be made if data about the person's medical conditions requirements are more accessible to medical practitioners, regardless of when and where, because time and place will no longer be as much of a roadblock in the smart world of the future. And by the same token, with more automation and digitalization and computerization and connectivity and networking, human error will plummet. Fortunately, there will be also fewer car accidents if the infrastructure of roads are outfitted to become smart with self-driving cars and monorails, perhaps, and crime will go down. It would be much harder to commit a crime and get away with it. Crimes like fraud, I imagine, would become next to impossible, I suppose. And the little anti-transhumanism Adam sitting on my shoulder whispers into my ear that crime and antinomianism is a necessary part of the human fire, that vitalism, that rebellious, dare I say, even Promethean spirit, until until one reads just what truly horrific things people still do to each other, the worst. So smart cities would be worth it for that dramatic decrease, or what I hope will be a dramatic decrease in extreme suffering at the hands of, criminals like serial killers, and even if someone does inflict the worst suffering, get away with it even temporarily for a few days, they will be easier to track down and brought back into custody. Thank you, Sharif.
Thank you. Thank you. This is an excellent discussion, and I want to share more good news that 25 October, we have some exclusive discussion. Beside that, we have more discussion. We are working with BBC, we are working with International Chamber of Commerce, few developing nations, Prime Minister Office, University Grant Commission, Planning Ministries. So World Talent Economy Forum, already the Asia Pacific, different government, corporations, academia, they start to believe that we can contribute for national development. So the board of advisors, our ambassadors, our scientific committee members, our speaker, they are our real asset. They can change human life, they can contribute for humans. So Professor Donald, Professor David Smith, and Mr. Adam, I want to give you special thanks for your continuous support for World Talent Economy Forum. And our audience, I request to share our content with your government, with your academia, with your uh, uh, corporations. And I believe with the collaboration is the key. With the collaborations, we can solve many problems. And now we live in the global world, and we have to minimize many problems. So that's why we need more support from developed nations. We need uh, more scientific, more technology based support from them. And beside that, we have humans. So human life progressions depends on modern science, engineering, and technology. And World Talent Economy Forums actually advocate for modern science, engineering, and technology. So thank you everyone for joining today's sessions. I directly want to go for the concluding remarks. I want to start from Professor David Smith.
Industry 4.0 is going to be as profound as the first, second, and third industrial revolution. The biggest difference is the time of diffusion. If you look at the diffusion theory, we are breaking all types of records as we're diffusing this technology globally. And we're diffusing it in a way that is changing society, changing people's lives, and beginning to be able to rapidly enable entrepreneurship like we haven't seen in a long time. And I think it's very important as we look at that. The concept of entrepreneurship is not just for an individual starting a company. Uh, Existing companies can be entrepreneur and they can set up innovation entrepreneurship labs inside the company. We've seen many of the major companies do that. Entrepreneurship can be at universities. I'm a fellow at IC Squared and at Tankandu, where one of your other speakers is Fred as well. And they have authored a book called Entrepreneur Universities, which is a great way to understand how academia can take on an entrepreneurial feel and help advance the regions, the communities, and the world outside of their academic program. Um, we increasingly are coming into a technology-based economy, and those things are driving too. There's some excellent scholarly publications out that address each of those, which actually came out of the IC Squared Institute, Innovation, Creativity, and Capital, which was formed by Dr. George Kosmeski, a real innovator in the Technopolis space. And this is a place where the train has left the station on the start of Industry 4.0. And it's up to us as the people, the consumers, the producers, the scientists, the researchers, the engineers, and the lawyers to shape where it's going. But once again, we need to keep in mind that we have to produce it for humans to use. Robotics, humanoids are a big part of Industry 4.0 going forward, but they have to begin to have the control. There was a great article just released this week about how Sophie, the first humanoid that has a nationality, now wants to have a baby robot, a baby humanoid, because she's learned from using her machine learning the importance of family and connectiveness. So even the AI that's being used and the sensors and things in Industry 4.0 is even telling the humanoid things that people are important, and that your relationships are one of the keys to being successful, and this cannot be lost in Industry 4.0. So I'm thrilled where it's going. I want to be part of helping shape where it goes, because this really is a global thing that's going to have the same impact as the prior three industrial revolutions.
Thank you, Professor Donald.
Here, it's easier to hear me when I'm unmuted. Yeah, I see it more less as a break, as an evolution that's taking place at different speeds in different places. But you know, it's kind of a laundry list of things that you want to be able to look at as a student. The Internet of Things has so much data. You have to learn how to be able to manage large amounts of data. That's where artificial intelligence comes in. So all of these things are paths that you can take. And as I often point out, there's administrators are necessary, lawyers are necessary, all these different things are necessary. Interestingly enough, I looked at the list of the top 10 most money-making professions, and guess what one of them is? Philosophy.
Mm-hmm.
Philosophy. So you have a tendency to think that, oh no, if I take these sciences, and I was talking to an Indian woman just yesterday that I met walking down the street, and we talked, and she was an engineer, and she said she let her kids do anything they want. One of them got a degree in history and then worked for McKinsey and is making a fortune. And her point was that it's about being able to solve problems, not necessarily learning some particular technical skill. So for young people, I would recommend that. And then at the higher level, for companies and nations and organizations, the thing that David and I were harping on about standards is absolutely critical. And being open, if you try and hold it to yourself, it's going to die. The only way that you're going to be able to make an innovation thrive is to have a team, but not just a team. Society and the world in general has to accept and adopt what you are doing. And then that's the only way that it thrives. You can't sell it unless people accept it and value it. So everything that you do has to be something that you're doing with other people, and never forget that. I want to say one thing mentioned to talk about what Adam was saying, and then I'll finish, which is that I find the thing about privacy really interesting, because I think if you're in a village in the developed world or even the United States, you find out that you have absolutely no privacy. I mean, everyone knows everything that you're doing, and they watch you like a hawk. They know if you've glanced at a woman. I mean, as a man, you glanced at a woman in a way that might indicate that you're interested in her. I mean, they know everything about you. And so in reality, we have very little privacy. I mean, so what privacy means to somebody like that and what privacy means to somebody who lives in a city where people are more private is different. There's no one thing that privacy means. And I'm personally not too worried about privacy on the internet, because why would anybody care about me? I mean, the worst that they can do is find some way to try and sell me things that they think I'm going to like. But I'm immune to advertising. I have ad blockers, and I just completely ignore it, or actually it repels me. So I probably often wouldn't buy things that I see advertised. It works the other way around with me personally. It's an interesting subject. It's something that's not black and white by a long shot. But back to Industry 4.0, there's a lot of parts to it, as I said. The mechanical engineering, electrical engineering, law, business. That's where you go to work for McKinsey. And all of those kinds of things require you to be verbally fluent. You'll do best if you're verbally fluent, have good social skills. And so don't neglect your education in reading and writing and literature and psychology and things like that, because that'll be your superpower no matter what you do. There you are.
Thank you. Mr. Adam.
Yeah, I really like what Mr. Donald said there. Maybe my concerns reveal a guilty conscience. I like the village metaphor as well. As something that didn't occur to me actually. But yes, it's not too pressing of an issue if you have nothing to hide. And like you said, I'm certainly not that dangerous. So yeah, hopefully they won't care about me either. But I also like to think how much of a privilege it is to witness this time in our human history. And end of historical figures would be very jealous of us sitting here about to step into this new world. Like what Mr. David said, this incoming revolution will be more dramatic than the previous historical industrial revolutions of the past. And technology does instill some measure of fear. If someone criticizes a tech development and it is apparent that it comes from a place of fear, I've seen it happen. People will come back at them with, "Oh, you're just afraid," or "You're biased by feelings of fear. What are you scared of?" And absolutely, people are scared. Fear is a normal, very useful human emotion, and we should listen to all of them and all of our emotions and not censor any feeling or emotion, because, like we established already, this Industry 4.0 epoch will be more dramatic than anything we've ever seen before, potentially. And it's something I really do wish to be a part of, despite some of my concerns outlined earlier in the discussion. And it will also be a great honor to help shape it and to help guide it in the right direction. So thank you.
Thank you. Thank you. Thank you, everyone, for joining today's session. So bye-bye and take care.
Thank you.
Thank you.